Fusion Mobile, quality e-learning experience on the go.
Good day, you are welcome to Fusion Mobile e-learning class. My name is Bolaji. I'm here to take you a subject, mathematics, and the topic is approximation. 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 We all know that sometimes when we are solving questions which involve decimal places, significant numbers that can be converted to significant numbers, approximations. Approximations of numbers could be in tens, could be in hundreds, could be in thousands, depending on the value of our result. Approximations give us a clue about precise numbers or degree of accuracy. For example, let's consider this number line. This is 4, 3, 2, 1, 0. 5, 6, 7, 8, 9, 10. Now, consider this number line. We cannot round up in this aspect because it's not up to 5, considering our number line. This our number line shows our movement. Now, from 1 to 4, we discovered that we cannot round up to 1 because this place is round down to 0. As our movement as shows, this is round up to 1. Why do we round up to 1? From the number line I drew, this is round down, this is round up to 1, round down to 0 because it's not up to 5. When it is up to 5, we'll round up to 1. When it is up to 4, we'll round down to 0. So approximation is a method of assuming precise value to figure. Approximation is a method of assuming a precise value to figure. Let's take for example where we have approximate 2783 kilometer to nearest 10. 2783 kilometer to nearest 10. 2783 kilometer to nearest 10. Approximate 2783 kilometer to nearest 10. We discover Abaco gives us a knowledge of how to count numbers. Look at here, we remember in JS1 when we deal with Abaco, where we have thousands, where we have 100, where we have tens, where we have units. We have thousands, we have 100, we have 10, and we have unit. And they say approximate 2783 kilometer to nearest 10. We discovered that we are dealing with tens, which is 83. 83 is about 10 because this is 10 units, tens and units. So if we also approximate this kilometer to nearest 10, it means this 83, this unit here, is not up to 5. Therefore, we have to round down to 0. That was why I drew a line, round down to 0. This is 3. It lies in the round down to 0, the number line I drew. Therefore, the answer to this is 2780 kilometer because we round down to 0. this 3 is not up to 5. So the answer to this, approximately 2783 kilometer to nearest 10 is 2780, because 83 is not up to 5. Then we run down to 0. Also, let's consider this value 2783 to nearest 100. Approximate 2783 kilometer to nearest 100. Now, I told you Abacus gave us a knowledge of what is thousands, 100, tens, units. Now, approximate this value to nearest 100. How do we find 100? I told you consider this 100 and this is 10. We discovered that we have 783 in this value. So you ensure that this value is greater than half of 100. Therefore, 783 can be approximated to 27,800 kilometers, because 83 is greater than 50, is more than half of 100. So if we want to approximate this value to nearest 100, is 272800 kilometers. Okay, I'm confident that you understand approximations of value, approximation of figure. I would like to give you one question on the example we have solved earlier. Approximate the same number to nearest 1,000, because I show you 1,000, I show you 100, tens, units. Approximate 2783 kilometer to nearest thousands. Now, we discovered that we have 2,783. That shows that it's more than 2,500. So, therefore, because we know that half of 1,000 is 500. Therefore, to approximate 2,783 to 83 kilometers to nearest 1,000 is because 500 is greater than 1,000. Is half of 1,000. And we have 783. Therefore, this 783 is above 500. We can approximate 2,783 kilometers because it's more than half of thousands. 783 is more than half of 1,000. Therefore, it can be approximated to 3,000 kilometers. So, therefore, 2,783 kilometers is approximated to 3,000 kilometers, because 2,783 kilometers is more than half of thousands. 783 kilometers is more than half of 1,000. Considering my number that I underline, 783 is more than half of 1,000. So it's easy for us to approximate 2,783 kilometers to 3,000 kilometers. I am confident that you understood this topic, approximations, because it gives us a precise value of a figure. I would like you to do these evaluations so as to test your ability on approximation. Wow, you've gotten the answer correctly. Let us proceed by knowing this subtopic under this approximation, which is called percentage error. Percentage error. Sometimes when we are doing measurements, we might be wrong. Maybe we are given an assignment to do to measure a piece of land, and in our eyes of understanding, we might think that the answer is correct, not knowing that we have an error which can affect our value. This error affects our precise value. As we dealt with approximation earlier on, now we can have an error in terms of measurement. This gives us a clue to what is called percentage error. Percentage error. Percentage error might not give us the precise value, but it gives us a degree of accuracy, because there is difference between precision and accuracy in measurement. Therefore, what is percentage error? Percentage error has an acronym of having PE. PE means percentage error, which is equal to actual error over actual value times 100. Actual error over actual value times 100. For example, let me give you this question. A rope of length 50 centimeters is to be measured by a girl to be 14.4 centimeters. Find the percentage error. This example gives us a clue that in a class whereby we ask a girl to measure a distance which covers 15 centimeters, she measured it to be 15 centimeters, and at the long run, she made a mistake of measuring 14.4 centimeters. Find the percentage error. That is a rope of length 15 centimeters, and she measured it to be 14.4 centimeters. This example gives us an illustration of error found in a measurement. That is a rope of length 15 centimeters. She measured it to be 14.4 centimeters. This is the actual length of actual value, and this is the actual error. 14.4 centimeters is the actual error because the rope of length is 15 centimeters, and she measured it to be 14.4 centimeters. So how do we know this percentage error in this question? Okay, the question is that the girl measured the rope to be 14.4 centimeters, and the rope is actually 15 centimeters. Therefore, the actual error in this is that 15.0 minus 14.4 centimeter over 15 times 100, which is equal to 15.0 minus 14.4, which gives us 0.6 over 15 times 100. 0.6 over 15 times 100, and is equal to 60 over 15. In percentage, 15 year 1, 15 year 4. So the percentage error is equal to 4%. That is 60 over 15, which is 4%. I am confident that you understood approximations, you understood the definitions, how to approximate numbers to a precise figure. Also, percentage error in terms of considering measurement, to know the degree of accuracy. I would like you to do these evaluations so as to test your capability on how to approximate numbers to a precise figure. Wow. Thank you, because I know that you understood this course because of the evaluation you have solved. I will like to see you ahead of our field topic that we're going to study. Thank you.